Okay, so we have some problems. Only one of these is really relevant to your homework. So on a quiz. And if today, everybody gets full credit in the quiz just for showing up. From now on, quizzes are on a 1 to 3 scale. You get 1 just for showing up. And then the other 2 points, depending on if you get it right or mostly right, or you get something right, but not the whole thing. Okay, so that's fairly straightforward. Gotta tilt this screen a little bit so I can make sure that we're focused. Okay. So let's work these. Hey, 3. That's the worst 8 that I wrote with the bad chalk. Anyhow, 3/8 plus 5/8. Now, the idea behind this is simply, you got how many eighths do you have? You have 3 of them here and you have 5 of them here, right? So when you add them, you have 3 plus 5 over 8. Okay? Now you want to write that step out with the plus there because there's a plus here, right? Because this means you're doing 3 of these plus 5 of these. So then the total is 8 over 8. You write out this intermediate step here because, if you add 3 and 5 and accidentally get 15 because you multiplied when you're thinking add, I won't necessarily know where that 15 came from. But if I see 3 plus 5 over 8, that much of the problem is correct. If you just write down the wrong answer, the whole problem's wrong. That makes sense? So at this point, you got half credit in that problem already. Okay. And then you add them up, you get 8 over 8. And if I ask for it to be reduced, of course, then you have to say, well, that's just 1. I think everybody knows that 8/8 is 1. Again, a picture that goes with this, it's really, I think, kind of important to be able to make the picture. So if here's 0 and here's 1, then here's 1/2. Halfway between 1/2 and 1 is 3/4. Halfway between 0 and 1/2 is 1/4. And if I divide each of those intervals in half, I have divided the interval from 0 to 1 into 8 pieces. And then 3/8 is this much. 1, 2, 3, right? 5/8 is 5 of them. That would go from here to here. So if I add 3/8 and 5/8, well, here's 3/8. Here's 5/8. If I add 3/8 onto the end of 5/8, I see that 5/8 and 3/8 add up to 1, which is 8/8, and I understand what the fractions mean. So I really recommend that you draw these pictures every once in a while, show that you know what fractions mean. And it's not important to show me that you know what the fractions mean. It's important to reinforce what the fractions mean for yourself. Okay, so when you see me draw these pictures once in a while, do the same thing. Show yourself that you know it. And if you aren't real sure of it, if you've never seen anything like that, I'd recommend you draw the pictures for the, as best you can, for the problems in this first assignment. Just go back, look at the assignment, draw the pictures. Get another idea in your head, it'll make everything easier. Might take you 20 minutes, but they're probably worth the time. Okay, so nothing to that. Okay, now your assignment didn't involve multiplication, and I don't think that actually didn't look at it. Involved something else, but okay, 3/8 times 5/8. We did this before. You just multiply the numerators and multiply the denominators, and you get 15 over 64. Now, what's actually going on here, and you might not relate to it that well, but here's 5/8. If you take 3/8 of that, 3/8 is a little less than a half. So you're gonna have a little less than the 5/8. Well, if I do another division, I've got this divided into 16 parts, another division would be 32, another division would be 64, and I've count over 15 of them. But I couldn't even do that with chalk. The chalk line is too thick, 64 units, and just kind of be a continuous blur of chalk, wouldn't it? But can you imagine, dividing this 3 more times? Dividing every interval in half 3 more times, you'd have 64 of them. And you have to have 15 of those. Okay, you might understand that, you might not, and if you don't, that's okay. If you do, might be helpful to you. 2/3 plus 7/5. I'm gonna draw this. I divide the interval from 0 to 1 into 3 equal parts. Then there's 2/3. If I divide the interval from 0 to 1 into 5 equal parts, it's like on these green lines, 1, 2, 3, 4, 5 parts, okay? And of course, 7/5 would be 7 of those, so I'm gonna have to make 2 more of those out beyond 1. So 7/5 is like about this big. Now, if I add 2/3 to 7/5, I'm gonna have to go further than this. I'm gonna be out there around 2. It'll be kind of close to 2 probably. Okay, just looking at it without being real analytical. So I know that my answer is going to be bigger than either of these numbers. If I was to add the numerators and add the denominators, I'd get 9/8, which would be about here on the number line. Okay, it's not nearly out far enough. Okay, so we don't add the numerators and the denominators. That's not the rule. Multiplication is easy. You just multiply the numerators and denominators. Addition is a little more challenging. When you don't have the same denominator, now if you got the same denominator, you just say, okay, I got that many eighths and that many eighths, so I get this many eighths, and here's the steps. And you write the steps so you remember the rule. So when you have to do it with algebraic expressions, you know what the rule was, okay? So in other words, we're spending time on this because it's going to become important later on in this course and in the pre-calculus course. Okay, well, 2/3 plus 7/5. How do we do this? We have to have the same denominator. Well, if I was to divide each of these thirds into 5 parts, or alternatively, each of the fifths into 3 parts, then I'd be able to do everything to find my chalk, which is over here, Okay. Okay, if I did that, I'd be able to do something like this. I can divide this into 3 parts. Divide this one into 3 parts. I divide this one into 3 parts. I divide this one into 3 parts. Divide this one into 3 parts. This one into 3 parts, and this one into 3 parts. Now, how many parts do I have between 0 and 1? If I count the small marks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 6, 9, 12, 15. I get 15 of them out to 1. There are 15 little intervals there. Okay. And I see that 5 of those intervals corresponds to 1/3. and 10 of those intervals to 2/3, whole thing to 3/3, which is 1, and so forth. Okay, so there's kind of a visual of what we're doing here. And if that's helpful, there's a picture. Okay. What it comes out to is if we divide our intervals up into 15 parts, we can add these. Okay. Now, the way we do that is we say we find a common denominator. Another way to understand this, of course, is we know that we can add fractions if they have the same denominator, right? Okay. So we got to find a way to express these fractions with the same denominator. Well, 2/3 is the same as 2/3 times 5/5, because 5/5 is just 1. And when we multiply 2/3 by 1, we still have 2/3. Except if we multiply by 5/5, it's going to look like 10/15. Well, 10/15 is the same as 2/3. It reduces to the same fraction. It just has different numbers in the numerator and denominator. Okay, and then if we multiply 7/5 by 3/3, notice that our denominator here is going to be 15, our denominator here is going to be 15. So this is 31/15. Now 30/15 is 2. 15 goes into 30 twice. So this is 2 1/15. It's a little over 2. That's consistent with our picture. I can see that if I go this far from here, I'm going to end up out here around 2. This is 0 and this is 1. 2 is going to be out around here. This arrow plus this arrow is going to be around 2. And our method of adding fractions is going to give us something around 2. Now let's do a couple more examples of this before we go on to some of these other. Let's try. Let's try 3/5 plus 3/4. Now, what we want to do is we want to find a number that you can divide by both 5 and by 4. Okay, so we're gonna let's do this now. Okay, write down on your paper, I just got a circle. Write down a couple of numbers that would be divisible by both 5 and by 4. And of course, if you're a distant student, you write those down. Don't wait for me to tell you what they are. Come up with your own numbers, okay? Okay, so numbers divisible by 4 and 5. Well, the smallest one is 20. Okay, there are other numbers. 40. And so forth, okay? We want to use the smallest number that's divisible by both 4 and 5. Now, you can always get a number divisible by these two, you just multiply them. And 5 times 4 is 20, and it turns out that's the smallest number that's divisible by both 4 and 5. So now we want to make these into fractions that have denominator 20. Now, 3/5 has a denominator of 5. What are you going to have to do with 5? In order to get denominator 20, you're going to have to multiply it by 4, right? So we want 3/5 times another fraction that has to have denominator 4 if we're going to get a denominator of 20. And of course, if we multiply by anything but a fraction that's equal to 1, it's going to change the value of 3/5. So we keep the value of 3/5 the same as it is. We're just going to change what it looks. Okay. And then 3/4. We multiply by 5/5. Okay. And the rest is easy. So go ahead and multiply these out and then add them. See what you got. Okay. So everybody did well with this. 3/4 over 5 times 4 is 12 over 20. I'm sorry, I didn't leave myself enough room here. I'm having to write things kind of small. But I debated about bringing it down here, but we're going to keep it where it is. It's 12 over 20 plus 15 over 20, which is 12 plus 15 over 20. That comes down to 37 over 20. Now you might have trouble reading that, but I think everybody's got that. I think everybody got 37 over 20. Couldn't read all of them. If you didn't, you get the 12 and the 15. Make sure you write out this step. Not sure I saw that step on the paper. Okay. You want to write out every step so you reinforce it so that you're not going to know to use it when it gets harder later in the course. Okay, let's do one more example. Let's try five over 6 plus 7 over 9. Can you give me a number that's a multiple of both 6 and 9? Or a number that's divisible by both 6 and 9. So that means the same thing. Okay, now, it's pretty easy to see that 18 is a multiple of both 6 and 9. And that's what everybody wrote down then. People wrote down 36, probably wrote down 54. The easiest multiple to get, if it's not obvious, is you just multiply the two numbers. That would be 54, right? 6 times 9 is 54. At least was last time. Okay. But it's easier to use 18. So it's pretty clear. Everybody saw that it's 18. Because 6 goes into 18 3 times, 9 goes into 18 2 times. Any multiple of 18, 180. Okay. 90. Any multiple of 18. Now we want to use the smallest number. We use 18. So to get a denominator of 18, we have to multiply 5 6 by 3 over 3, multiply 7 nines by 2 over 2, which equals 15 over 18 plus 14 over 18. Now we say, well, we got how many 18s have we got? We got 15 of them here, we've got 14 of them here. That makes 15 plus 14, 18ths, which is 29 18ths. Okay. So what if we have something like oh, let me think of a good one here. Okay. Can you give me a number off the top of your head? And if you can, I'll be impressed. It's the smallest number that's a multiple of both 36 and 27. Now, you can always give me a number that is a multiple. Thirty-six times 27 is a multiple, but hopefully there's a smaller one. Now, we could do this. We could do 17 over 36 multiplied by 27 over 27. Our denominator would be 36 times 27, right? And then we could multiply this by 36 over 36. We'd have 27 times 36. It's the same thing. What is 27 times 36? Can you do that in your head? Well, okay. I could, but it'd take me minutes. I'm not going to do it. But that'd probably be wrong. So it's advantageous to figure out what the smallest common multiple is. So you don't have to use big numbers, at least not numbers any bigger than you think than you really need. Okay, so I'm going to show you how you get that. First of all, I'm just going to do it down here, 36. What's the smallest number you can divide 36 by? Just hold up fingers. Smallest number that'll divide into 36. 2. The smallest number other than 1, okay? Yeah, you divide 36 by 2, it's an even number. You divide 36 by 2, you get 18. Okay? Now, 2 is a prime number. There's no number smaller than 2 that divides into 2. Okay? What about 18? Can you divide 18 by something? What's the smallest number you can divide 18 by? Show me with your fingers. Smallest number would be 2. It's an even number, so divisible by 2. So 18 is 2 times 9, right? Now 36 is 2 times 18, means it's 2 times 2 times 9. So every row here is going to multiply out to 36, right? So there's a bring this 2 down here because we're going to need it. I'll bring this 2 down because we need it. Now, what's the smallest number that divides 9? 3. Okay. Okay, so we can say that 36 is 2 times 2 times 3 times 3. And we could also, of course, write that as 2 squared times 3 squared, but I kind of prefer this. There's a rule that you can use with the exponents, and that's what open math is going to try to teach you. It doesn't necessarily make any sense unless you see something else. Now, 27, we do the same thing. We get 3 times 9, which is 3 times 3 times 3. Which, of course, we could write as 3 cubed. Okay. And looks like, let me see if this is the best way to do it. Okay. So there we have it. And so we're just a little further there. We go. Okay. What are we going to do about this? Well, the number we're looking for has to have enough 2's in it that both of these numbers will fit. Okay. So how many 2's are we going to need in the number we're looking for, the smallest multiple of both? Let's call that the least common multiple. Okay. How many 2's are we going to need? How many 2's do we need if we're going to contain 36? 2 of them, right? Of course, right there it is in the exponents, so that makes sense, but we see them right here. Okay, so we're going to need a couple of 2's. Now we only need 2 3's to make up 36, but that's not enough to make up 27. How many 3's do we need for 27? We need 3 of them, right? Now, if we have 2 2's and 3 3's, then we got enough 2's and 3's to contain both of these numbers, right? We got them both covered. So we need leave myself room to write everything I was going to write. I should have thought it through first. We need 2 2's and 3 3's to contain both 36 and 27. We don't need any more than that. But we got to have that much. So the least common multiple of 36 and 27 is this, which multiplies out to 108. Now my mental arithmetic is still pretty good. And I could pretty easily see that it's 108 because I know 36 was in 108, so it's 27. But you get the numbers a little bigger, a little more complicated than this, and I'm not going to be able to do it in my head, but I can always do this. You can always do this, and open math is going to tell you more about it. It's going to give you a rule that says whatever the biggest exponent of 3 is here, that's the one you're going to use. And whatever the biggest exponent of 2 is, that's what you're going to use. Okay. Now that's a rule, but the rule doesn't really show you why it works. If you think of it this way, you see why it works. Because this number has to have everything this number has, meaning it has to have at least a pair of 2's. And it has to have everything this number has, which means at least you have to have 3 threes. There it is. Okay, well now. I'll get myself room to do this. We're gonna do 17 over 36 times 3 over 3. Now, why 3 over 3? Well, 36 only has everything that 27 has, except 1 3. It needs an extra 3. Okay, so if you multiply it by that extra 3, you're going to get the 108. And 27 lacks a pair of 2s. 2 times 2 is 4. So we're going to do 27 over, sorry, it's 19 over 27. Times 4 over 4. That equals 51 over 108 plus 76 over 108, which is 137 over 108. And I'm pretty sure